Have you ever stopped to wonder, what makes up everything around you? This question has intrigued scientists for centuries and led to the discovery of the most fundamental building block of our universe: matter. Imagine holding an apple. Now that apple is not just an apple. It's a complex structure of atoms, the smallest units of matter, binding together to form molecules and creating the substance that we recognize as an apple. It might seem simple to us, but the reality is a fascinating tapestry of science. Everything we see, touch, and interact with, from the vast galaxies in our universe to the tiniest grains of sand beneath our feet, is made of matter. All the stars in the night sky, the trees in the forest, the mountains standing tall, the buildings in our cities, and even the air we breathe, they all consist of atoms and molecules dancing together in an intricate ballet of nature. Atoms come together in different ways to form a plethora of substances, each with its own distinct properties. This is why water flows and rocks are hard. This is why helium floats and iron sinks. This is why sugar is sweet and lemons are sour. All these properties are dictated by the type and arrangement of atoms in their molecules. But matter is not just about atoms and molecules, it's about energy too. The energy that binds atoms together, the energy that causes them to move, the energy that brings about change. It's a dynamic, ever-changing, never-resting entity. And it's not just the physical world around us, even we ourselves are made of matter. Every cell in our bodies, every strand of our DNA, every thought in our minds, they're all the result of billions of atoms interacting in complex ways. We are, in essence, walking, talking assemblies of matter. So, matter is the building block of our universe, but how does it change? This question leads us to the next chapter of our exploration, so sit tight as we delve deeper into the mystery of matter and its transformations. Water, ice, steam, different forms, but the same substance. Ever wondered how? Let's dive into the fascinating world of matter and its transformations. We encounter matter every day, in all its different forms, solids, liquids, and gases. But how does one form transform into another? The secret ingredient? Temperature. Imagine a chilly winter day. You're outside with a cup of hot chocolate. As you hold the cup in your hands, you're holding a liquid. But what happens when you leave that cup in the freezing cold for a while? It turns into a solid, right? That's because the temperature has lowered, causing the hot chocolate to freeze and change from a liquid to a solid. This is a physical change in matter. Now let's consider another scenario. You're boiling water to make tea. As the water heats up, it turns into steam, changing from a liquid to a gas. Again, this is a physical change. The water hasn't become something else, it's just changed its state. In both scenarios, the water, whether in your hot chocolate or your tea kettle, changes its form due to temperature changes. But no matter what form it takes, solid, liquid, or gas, it's still water. The fundamental composition of the matter remains the same. So, when matter undergoes a physical change, it might alter its state, appearance, or form, but its basic identity remains unchanged. It's like an actor changing costumes for different scenes in a play. The actor's appearance may change, but the actor remains the same person. In the world of matter, these changes of state are reversible. You can melt the frozen hot chocolate back into a liquid, or condense the steam back into water. It's a beautiful ballet of transformations, all choreographed by temperature. Physical transformations are intriguing, but there's more to the story of matter's metamorphosis. So, stay tuned as we delve deeper into the mystery of matter in the next scene. What if I told you that you could turn lead into gold, not by magic, but through a process called chemical change? Let's delve into the intriguing world of alchemy, an ancient practice that sought just that. Alchemists were not just misguided proto-chemists, they were the dreamers who tried to understand the fundamental nature of matter and transform it. Their quests, though shrouded in mystery and magic, were the stepping stones to modern chemistry. Now, let's demystify this a little. A chemical change, unlike a physical change, alters the very nature of matter, creating new substances. Imagine baking a cake. You start with separate ingredients: flour, eggs, sugar, and butter. Once you mix them and bake them, you have a cake. You can't just pull out the original flour or eggs anymore. They've undergone a chemical change. A more dramatic example is the burning of wood. Here, the wood, in the presence of heat, transforms into ash, smoke, and gases. The wood is gone, replaced by entirely new substances. These are examples of chemical reactions, the heart of chemistry and alchemy alike. But it's not all cakes and campfires. Chemical changes are everywhere. The food we eat, the air we breathe, even our very bodies are sites of constant chemical reactions. Photosynthesis in plants, digestion in our stomach, the rusting of iron, the charging of a battery, all are examples of chemical changes. To those ancient alchemists, the dream of turning lead into gold was a quest to master these chemical changes. Today, we know it's not as simple as they hoped. Changing lead into gold would require nuclear reactions, a whole other level of complexity. Yet, their fascination with transformation wasn't entirely off the mark. We do transform matter, just not in the way they imagined. So we can change matter physically and chemically, but what does this mean for us? Stay tuned as we dive deeper into the mastery of matter's transformations in our next section. Why does it matter, no pun intended, that we understand these transformations? Well, let's dive right in. You see, the study of matter and its transformations is not just an abstract science, it's a cornerstone of our daily lives. It's the silent partner in the dance of existence, the invisible hand guiding the course of our reality. And when we start to understand it, we unlock a world of possibilities. Think about it, every moment, every breath you take, every beat of your heart. It's all the result of a ceaseless flow of matter transforming from one state to another. But it doesn't stop there. Understanding these transformations opens up new realms of technology that were once thought to be the stuff of science fiction. Imagine, for instance, a world where we can manipulate the very fabric of matter to create materials that are stronger, lighter, and more durable than anything we've seen before. A world where we can harness the power of atoms to generate clean, limitless energy. That's the promise of mastering matter's transformations. And it's not just about technology, it's about medicine too. By understanding how matter transforms at a molecular level, we can develop new treatments and therapies that could revolutionize healthcare. We could potentially cure diseases that are currently untreatable, and extend human lifespan beyond our wildest dreams. But it doesn't end there. By unraveling the secrets of matter, we're also unraveling the secrets of the universe itself. We're peering into the very heart of existence, gaining insights into the nature of reality that have profound implications for philosophy, theology, and the human condition itself. So why does it matter that we understand these transformations? Because they're the keys to unlocking a future of unimaginable potential. A future where we can shape our world in ways we can barely begin to comprehend. And that, my friends, is why it matters. From the grand cosmos to the tiny atom, matter and its transformations are the essence of our universe. So we've journeyed through the intriguing world of matter and its transformations. In our exploration, we've seen that matter, which makes up everything we touch, see, and even breathe, can change in both physical and chemical ways. We've learned that a physical change doesn't alter the core identity of matter, but instead its appearance or form, like water turning into ice or steam. On the other hand, a chemical change involves a transformation at the molecular level, creating entirely new substances, as we see when wood burns to become ash and smoke. Understanding these concepts isn't just scientific trivia, it's a key to unlocking mysteries in our everyday world, from cooking to climate change, and it's a cornerstone of scientific progress across fields from medicine to material science. The next time you see a change around you, remember, it's just matter dancing to the tunes of science.